Welcome back, folks. Rational expressions and equations, lesson 4, addition and subtraction of rational expressions. Completely botched the first attempt, so this is my second attempt, but here we go. Remembering that when we're adding and subtracting rational expressions, it's just like adding and subtracting fractions. We need to have a common denominator before we can do that. And in order to get that common denominator, sometimes it involves factoring our denominators so that we can see what's common in order to determine the common denominator. Something else that we also have to be very aware of is that even if a question does not specify, although this one does, non-permissible values, okay, if it does not specify and it just says simplify, we still have to do non-permissible values. We always have to do that, regardless of whether or not it says to do it in the question. So they start asking you at the beginning here, making sure that you are aware it's something that needs to be done in hopes that you remember to do it later. So as we can see, so there's different terminology as well. Non-permissible values, stating the restrictions on the variable, okay, or determining what values for the variable make the expression undefined. Okay, so those are all the same terminology. So you can see that the first three examples do specify find the non-permissible values, but when we get into example 4, it just says to simplify, but it's implied we're already into the habit of finding non-permissible values, so we always have to do that, okay? Something to remember. Okay. So let's go to example 1, and we will start with finding our non-permissible values. So example 1, 5x. So remember, to find the non-permissible values, you're taking your denominator, saying, well, that cannot equal 0, and then you're solving for the variable. Divide by 5, x cannot equal 0. So in monomials, it's always really going to be x cannot equal 0. When we get into binomials and other things, it'll be different, but so I really don't need to do this 10x because it's still going to give me x cannot equal 0. And just to show you that, 10x cannot equal 0. Divide by 10, x cannot equal 0. So you get the same thing anyway, and we only have to state it once, okay? One other thing I wanted to preface for this video is that it's gonna probably be a little bit long because these questions do take some time to go through. If you find that the question or the example that we're working on is kind of simple and easy for you, then please feel free to skip it and move on to the more complicated ones, okay, towards the end in example 4, 5, and 6. Okay? Otherwise, I would expect that there'd be notes for all of these done. So question A, 3 over 5x minus 3 over 10x already have our common, or not our common denominator, our non-permissible done. We need to realize that our common denominator between 5 and 10 is going to be 10. And then common denominator between x and x is obviously just x. So we need to create fractions on 10x. Now this 3 over 10x is already on 10x. But then I think, well, what do I need to multiply by in order to go from 5x to 10x? Well, I need to multiply by 2. So I need to do the same thing for the 3. 2 times 3 is 6. And then I can make one fraction with one denominator, and I simply go 6 minus 3. 6 minus 3 is 3. 3 over 10x is your final answer, okay? So I'm going to show all the intermediate steps, or as many as I can, so that those of you that are trying to grasp this still can still see all of that, okay? So let's look at B. 4 over 5x plus 5 and plus 3 over 2x plus 2. So we look at our denominators and we want to factor those first. So I'm going to factor these. This is going to be 5x plus 1. This is going to be 2x plus 1. That's a 4, that's a plus, that's a 3. So now I'm going to do my non-permissible values. The 2 and the 5 out in front of those brackets, those are just constants. Those really don't mean anything to me. So I'm going to say, well, x plus 1 cannot equal 0. Subtract 1, x cannot equal -1. There's my non-permissible value. Now I'm going to determine what my common denominator is. My common denominator is going to include x plus 1, obviously, because that's in both already. The denominator on the left has to include a 5, but there's a 2 on the right-hand side, so it also has to include a 10. So 2 times 5 is 10. So my common denominator is going to be 10 times x plus 1. Well, what do I multiply 5 by to get to 10? I multiply by 2. So I'm going to multiply the numerator by 2. And what do I multiply 2 by to get to 10? Well, that's 5. I'm going to multiply my numerator by 5. Now I can write this all over one common denominator, 10 and x plus 1. 2 times 4 is 8. 5 times 3 is 15. 10 plus 15, what's that, 23? 23 over 10 bracket x plus 1. And of course here we would check to see if things reduce, but they don't, so we are complete. Okay. I think that's what all these examples in the first one do. They don't reduce, for a couple, I think. Question C. 1 over x squared minus 1 over x squared plus 2x. So now these may look like part of a common denominator, but this plus sign, this is one term, so we have to be really careful. Okay, so I still need to do some factoring on my denominator on the right-hand side, or the right-hand term. Oh, what happened there? Did I go back to the beginning? It did go back to the beginning. Okay, let's find our page. We are into lesson 4, correct? Should be somewhere right around here. Sorry about that, folks. There we go. Get rid of those pages. There we go. We have x squared cannot equal 0. So I'm going to square root both sides. X cannot equal 0. There's 1. And then I have x squared plus 2x, which actually I should factor first. I did it again. What happened there? I'm touching something on the bottom of my screen here. This is 1 over x squared. This is going to be 1 over, factor out an x plus 2. Okay. So now I can go over here. So I did my x. Actually, I did my x squared. Now I need to do my x and my x plus 2. I take each of those individually. X cannot equal 0. So that one's done. And I go x plus 2 cannot equal 0. Subtract 2, subtract 2. X cannot equal negative 2. There's your non-permissible values. Okay. Now, my common denominator is going to contain x squared and x plus 2. X squared and x plus 2. Remember, this x is part of x squared, so we only really need to multiply this side by x. Okay. Minus 1 over x squared, x plus 2. What do I need to multiply this by to get x squared, x plus 2? Well, that's x plus 2. 1 times x plus 2. What do I need to multiply this side here to get to x squared, x plus 2? I need to multiply by x. So this is going to be multiplied by x. Common denominator is now the same. X squared, x plus 2. This is going to be 1 times x plus 2, showing the intermediate step just because. Okay, x. Now I'm going to bomb my brackets on the numerator. I'm going to leave my denominator where it is. I don't want to expand that. I want to leave it exactly where it is. This is going to give me x plus 2 minus x all over x squared times x plus 2. X take away x is nothing, so that's 2 over x squared bracket x plus 2, and that answer is complete. Okay. So these questions do take a fair bit. They take a little while to work through. So like I said, this video has potential to be long. If you got that, that's great. Okay, but remember, these examples progressively get more and more difficult. Example 2, simplify, state the restrictions on the value of x. So we can, and hopefully you're at that point right now where you can very quickly look at the denominator of these rational expressions, especially if they are factored, and determine what those non-permissible values are, or for what those values make the expression undefined, or what the restrictions are on the expression. So here, Here, I can see that x plus 1 is going to say that x cannot equal negative 1. Here, x minus 2 cannot equal 0, so x cannot equal 2. Here, x cannot equal negative 4. And then this one is the same as this one, so I don't need to state it again. So over here, I'm going to say x cannot equal negative 1, 2, and negative 4. Okay. Simply stated, this is technically, well, this is what we're looking for. And if it's already factored like this, then this is okay to just write straight away if you can determine those. You got to get them right. If you don't get them right, though, you're going to lose those marks, part marks anyway. If something has to be factored, then I'd like to see the factor work somewhere within the question. Okay, so let's get rid of this stuff. Move on with the question. So our common denominator is already contain x minus 2. My left-hand side contains x plus 1. My right-hand side contains x plus 4. So I need to make my common denominator have 3 terms. X plus 1 was already here. X minus 2 was already here. And I need to add in x plus 4. If I'm adding it in the denominator, I need to add it in the numerator. Okay? Remember, the 5 was already there. Same with the other side. This was x plus 4. This was x minus 2 already there. And I need to multiply in the x plus 1. So I'm going to multiply in the x plus 1. 2 was already there. Now my common denominator now has all 3 of these things. Boom, 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 boom. X plus 1, x minus 2, x plus 4. My numerator is 5 times x plus 4 plus 2 times x plus 1. I expand using distributive property in the numerator. Boom, 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 boom. That's going to give me 5x plus 20 plus 2x plus 2 all over x plus 1, x minus 2, x plus 4. Okay? Always have to write the denominator each step. Combine like terms, that's going to give me 7x plus 22. I can see those are not going to factor, so I don't have to factor. If they did factor, I would have to factor that and do some canceling of terms, not terms, factors, over x plus 1, x minus 2, x plus 4. Complete. The page takes us to example number 3. P squared minus 1, 4 over p squared minus 1, plus 2 over p plus 1, state the non-permissible values. So we need to simplify and state the non-permissible values. Before I can state the non-permissible values or simplify, I need to factor this p squared minus 1. You should be able to see that that very quickly factors to p plus 1, p minus 1, because that is difference of squares, plus 2 over p plus 1. So I can see that my non-permissible value for p plus 1 is going to be negative 1. My non-permissible value for p minus 1 is going to be positive 1. And this p plus 1 is the same as our first one, so that's a minus 1. So if you're doing the side work, somewhere over to the side or scrap paper, you're going p plus 1 cannot equal 0. Minus 1, p cannot equal negative 1. And you're going to go p minus 1 cannot equal 0. Add 1, p cannot equal 1. So we generally would say p cannot equal plus or minus 1. And that's how we can simplify that. Now, again, remember, this side work in simple ones, if you can see it and it's already factored, then that's fine. You can just state the non-permissible values. But if you have to factor it, or if they're more complicated, then I would suggest doing those intermediate steps. Doing these intermediate steps, making sure that you do them correctly. Okay. Over here, I can see that my common denominator is going to include p plus 1 and p minus 1. So really, this side only needs to multiply by p minus 1. P minus 1. Okay. So this is another way that you can write these questions out and lessen the number of steps that you have to write out. So now I have a common denominator, p plus 1, p minus 1, p plus 1, p minus 1. And then this 4 stayed the same, plus 2 times p minus 1. I'm going to expand my numerator by distributive property, combine like terms, and simplify if need be. 4 plus 2p minus 2 all over p plus 1, p minus 1. Now I've run out of room, so I'm going to move up over here. 4 plus 2p minus 2 is 2p plus 2 all over p plus 1, p minus 1. Now, in a perfect world, we wouldn't have to factor and cancel anything else, but this question, this is the first one where we see in which the numerator does factor to 2p plus 1 all over p plus 1, p minus 1. Now I'm going to cancel. I can cancel this factor with this factor, and that will leave me a final answer of 2 over p minus 1. That is complete. Let's move on to example number 4. Okay, so this example number 3 was an example as we must always check to see our answers are in fully factored form. Just like factoring polynomials, we always do that last step. Okay? So here we have example 4, and then we have 5 and 6. Ooh. Example 4. Simplify. 2 over x plus 1 minus x minus 1 over 2x minus, x squared minus 2x minus 3. So before we can simplify, we need to factor our new denominator, and we need to find our non-permissible values. So hopefully you're at the point where you can see, well, this is going to factor by inspection. Two numbers that multiply to -3 add together to give -2 is going to be -3 and +1. So this term is x minus 1 all over x minus 3 x plus 1. Okay, my first term doesn't change. So this is 2 over x plus 1. My non-permissible values here, -1, here, +3, here, -1. So I can very simply say in my non-permissible values, x cannot equal -1 or 3. Okay, but if you're doing the side work somewhere, then somewhere your side work is getting done to determine those non-permissible values. Okay, for some of these easier ones, I'm going to start skipping the non-permissible value solutions stuff, just so that this video is going to shorten up a little bit, which I think will be most of the rest of the questions here. So now you can see your common denominator is going to contain x plus 1 and x minus 3. Which means over here, I need to multiply in, I'll change colors just to make it simpler. I need to multiply in x minus 3. Well, if I do it in the denominator, I need to do it in the denominator. If I do it in the numerator, I need to do it in the denominator, right? So now I can write one big fraction over x plus 1, x minus 3. Here, I'm going to have 2 times x minus 3 minus bracket x minus 1. So you got to put that term in a bracket. This is also the first time where we've seen this symbol being subtraction. Remember, when this is subtraction, we have to be very careful. There's a -1 here that we have to bomb in. I'll change that to a different color too, just so we can see it. Right? So now I'm going to bomb in the 2 here. I'm going to bomb in my -1 here. I'm going to combine like terms and simplify if possible. So this is going to be 2x minus 6 minus x plus 1 all over x plus 1, x minus 3. My numerator simplifies to x minus 5 all over x plus 1, x minus 3. And we would be done. Example B, question B. You can see both of these need to be factored. So I'm going to factor both real quick because they're factored by inspection. This is going to be 1 over y, two numbers that multiply to 2, +2, add to give -3. -2, -1. -2, -1. Over here, two numbers that multiply together to give -2, add together to give +1. That's going to be y plus 2, y minus 1. So our common denominator is going to contain y minus 1. Let's change colors here. Y minus 1 because that's common. Over here, and a y minus 2 and a y plus 2. So we have three terms. Because this left-hand side does not contain y plus 2, I need to multiply in y plus 2, which means I need to multiply it in the numerator as well. That's a y. Okay. On my right-hand side, this does not contain the y minus 2, so I need to multiply in my y minus 2. Now I can write one big fraction. Oops, wrong color. One big fraction over y minus 2, y plus 2, y minus 1. This is going to be 1 times y plus 2 plus 3 times y minus 2. Going to expand my numerator using distributive property. Okay, bombing. 1 times here, here, 3 times here and here. Simplify, combine like terms. Y plus 2 plus 3y minus 6 all over y minus 2, y plus 2, y minus 1. Y plus 3y is 4y, 2 plus -6 is minus 4, all over sorry folks, got a little distracted there. Y minus 2, y plus 2, y minus 6. No, not 6. I looked at the wrong number. Y minus 1. You can see our numerator factors has a common factor of 4, giving me y minus 1, all over y minus 2, y plus 2, y minus 1. And look, lo and behold, the y minus 1 is going to cancel with this one, leaving me with 4 over y minus 2, y plus 2. Again, do not expand your denominators. There's no need to do so. Final answer, complete. Okay, and that takes us to the end of that example. What number was that? Example 4. So now we are on example 5, which is over the page. So see example 5. What do we think you have to do? Factor both the numerator and the denominator. But there's something special in example 5 that you'll see that's going to help us out. And then, of course, in example 6, we need to factor the numerators and the denominators. And then, of course, remember, this is going to cause us to do that little negative trick thing, okay? So let's go back to example 5. Again, before we begin this question, we need to have everything factored. Luckily, all of these factor by inspection, so I can very quickly factor these. So when I factor these, my numerator on the left-hand side, x squared minus 3x plus 2 is going to factor 2. X plus 2, no, sorry, x minus 2, x minus 1. My denominator on the left-hand side is going to factor 2. Two numbers that multiply to 4, -5, x minus 5, x minus 1. Sorry, not 5, 4. It's minus 4. My numerator on the right-hand side is going to factor 2, x plus 6, x plus 4. My denominator on the right-hand side is going to factor 2, x plus 2, x plus 6. Now that everything is factored, I can do my non-permissible values. Again, these are nice and simple. This is going to be x cannot equal 4. This is going to be x cannot equal 1. This will be x cannot equal -2. This will be x cannot equal -6. So somewhere I write down x cannot equal -2, -6, 1, or 4. And it doesn't matter. To me, it does not matter what order you write those in. I know the book likes to write them from smallest to largest, but for me, it does not matter at all. Okay. Now, look at this question, though. This question is going to allow us to do this before we find a common denominator. Look, this x minus 1 can cancel with this x minus 1. This x plus 6 can cancel with this x plus 6. That's just like reducing a fraction before you do any work with it, right? So we can do that. That'll leave us x minus 2 over x minus 4 minus x plus 4 over x plus 2. So you can see my common denominator is going to be x minus 4 times x plus 2. So I can say, well, if that's what my common denominator is, I need to multiply this side by x plus 2. And my numerator as well. And I need to multiply this side by x minus 4. And my numerator as well. That's a 4. So now I have a common denominator. My common denominator is x plus 2, x minus 4, minus 4. And my numerator, x plus 2, x minus 2, minus x plus 4, x minus 4. Whoops, that's a minus. And we're going to expand our numerator using our distributive property, bombing, okay? And then simplify and combine like terms, right? So if you notice, this is actually difference of squares, correct? So x plus 2 times x minus 2 should lead to x squared minus 4. This is also difference of squares. X plus 4 times x minus 4 should lead to x squared minus 16. But I'm not going to do that. I'm not going to do that shortcut step because I find that many of you still are confusing this process a little bit. So I'm going to do all of the intermediate steps. I'm going to do my bombing first, outside, inside, last, first, outside, inside, last, making sure that I'm going to subtract all of this. So I'm going to put a big set of brackets around all of that. This is going to give me x squared minus 2x plus 2x minus 4 minus all of this, x squared minus 4x plus 4x minus 16, all over x plus 2, x minus 4. Run out of room, so I'm going to go jump up over here. X squared minus 2x plus 2x minus 4, that simplifies to x squared minus 4 minus, what's simplified in my other bracket? Minus 4x plus 4x, those disappear, x squared minus 16, all over x plus 2, x minus 4. Bomb in that negative sign, boom, boom, gives me x squared minus 4 minus x squared plus 16 all over x plus 2, x minus 4. X squared minus x squared, it's gone. Negative 4 plus 16 is 12 over x plus 2, x minus 4. And that would be complete. Question 6, show that 2a plus 7 over a squared plus 7a plus 12 plus 2a over 9 minus a squared can be reduced to this. So in order to determine that it can be reduced to that, that means we need to simplify this, right? And again, we should always do our non-permissible values just to make sure. So I'm going to factor, my numerators don't need factoring. This is going to factor to a plus 3, a plus 4. So I'm going to have 2a plus 7 over a plus 3, a plus 4, plus 2a. And I'm going to do the negative trick here so that this reverses. Negative 1, a squared minus 9. Now it's difference of squares. Now, a couple of things happen here. I'm going to factor this using difference of squares. Perfect square separated by a minus. That's going to factor to a plus 3, a minus 3, my 2 on the top. I'll come back to the negative 1 in a second. 2a plus 7, a plus 3, a plus 4. And then, of course, remember, we had this negative 1. We had this negative 1 here. Well, this negative 1 can also be written on the top of this fraction, correct? Because it can go top or bottom. And then this plus sign times the negative 1 is going to give us a subtraction. Okay. If you wanted to, you could still say plus a negative 2. Your choice. Either way, it doesn't matter. I'm going to leave it as a plus negative 2 just because I've moved it to the top, so that it might allow us a little bit more simplicity. My common denominator is going to combine a plus 3, a plus 4, and a minus 3. So I need to multiply my left-hand side by a minus 3 to get our common denominator. And I need to multiply our right-hand side by a plus 4 to get our common denominator. Now I have one common denominator, a plus 3, a plus 4, a minus 3, and then this is going to be a minus 3 times 2a plus 7, that's an a, plus negative 2, bracket a plus 4. Now I would actually do this just because I don't like that plus minus beside each other. And you can see the plus minus actually just works out to a minus, right? So that's where you would change it anyway. So now I'm going to do my bombing. Actually, I'll write that intermediate step out. A minus 3, 2a plus 7. This plus minus is going to change to just a minus, minus 2 bracket a plus 4. All over my common denominator, which is this. And I can do this. Let's try this. Copy, paste, and I can move it right there. Look at that. Okay. I'm going to bomb using FOIL on my left-hand part. Boom, 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 boom. And I'm going to bomb this in using distributive property. I'm going to combine like terms and simplify. So I'm going to work right to left, or left to right now. A times 2a, actually, will I have enough space? I might not have enough space, so I'm going to move up over here. A times 2a, a minus 3 times 2a plus 7 is going to give me, 2a squared plus 7a minus 6a minus 21 minus 2a squared minus 8a all over my common denominator. A plus 3, a plus 4, a minus 3. Oops. A plus 3, a minus 3, a plus 4. Combining like terms, you can see that this 2a squared and 2a squared are going to cancel. They're going to disappear. Then I have plus 7 minus 6 is plus 1 minus 8 is minus 7, minus 7a minus 21 all over a plus 3, a minus 3, a plus 4. You can see my numerator is going to factor. If I factor out a negative 7, I'm going to be left with a plus 3 all over a plus 3, a minus 3, a plus 4. And lo and behold, this will cancel with this. Negative 7 over a minus 3, a plus 4. Whew, that was a big one. Okay, Brings us to the end of the lesson. If you check Scolantis, you'll be able to see what questions are. I think I've posted all of the questions for all of the lessons for the remainder of the unit. Although I don't have the videos completed yet, they will be completed shortly and posted. And I guess we will see you next time.